Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Now we will discuss hardenability of steels. While discussing various heat treatment process, we talked about hardness and we saw that different heat treatment process give different hardness. But now we are talking of hardenability of steels. So before talking of hardenability, it would be better to discuss and differentiate explicitly between hardness and hardenability. Now we can define hardness as it is the mere of resistance to plastic deformation as measured by the indentation. Let's say we have a specimen for the hardness and we have a indenter this is indenter to measure the hardness of the material. Now after we push the indenter in the material, now how much the indenter went inside the material is the indentation. So we can say that indentation or the hardness measures the hardness of the material. Now if the indenter or we can say the for high hardness materials the indenter go less in the material and for low hardness materials the penetration of indenter is more. So we can say here the Harden ability has nothing to do with the hardness. So to describe hardenability, we can say it is the ease of formation of Martensite by Quench. As we discussed earlier that Martensite is considered to be hard and brittle material, and we take that this is the hardest material or the phase we get out of heat treatment process, and that is achieved through quenching process. Now the ease of formation of martensite by quench is described the hardenability of the material. So slow quench rate we can further elaborate as slow quench rate means high harden ability for that very material. Now let us see the time temperature transformation diagram for the case of plain carbon steel and alloy steel. And if we consider the plain carbon steel and we transform austenite by a very fast cooling rate so that it misses the nose of the C curves, so we end up with the formation of martensite. So we can say that easier for the quench, more hardenability we can describe as the easier for quench means high harden ability. This means that if we have more allowance or we may resort to low rate of cooling, so it means we are having more hardenability. And if we see the TTT diagram for the alloy steels, and we see here that the time lag that is more for the case of producing martensite. Here we have more time lag, so it means we have more, it has provided more window for opportunity for the material to transform to martensite. So it has more hardenability. So we can say the we have high hardenability for the case of alloy steels and low harden ability for the case of plain carbon steel. As we have seen in this TTT diagram, here the time lab that is shortened at the nose as compared to the time lag that is available for the case of alloy steels. Further, the concept of hardenability is more pronounced for the case of steels. Now with this we end our discussion here. Allah Hafiz.